All right, pre-calculus, this is the third video for 4.5. This last graph that we have to do on our own has everything in it, basically. So if we start to look, we've got an amplitude, this time of 4. Fortunately, there's no reflection this time. For the period, we take our normal period, which is 2 pi, and we divide by the b number, which in this case is 1/3. So dividing by 1/3 is the same thing as multiplying by 3/1. Oops, 3/1. So that's 3/1, so that's going to give me 6 pi for the period. Figure out my increments. I take the period and I divide by 4. So 6 pi divided by 4 would be 3 pi over 2. This does have a phase shift because there is something being added inside of the parentheses. So reminder, for our phase shift, negative c over b. So the c number is pi, so it'd be negative pi over 1/3. Multiply by the reciprocal, and that'll give me negative 3 pi. So there's a phase shift of negative 3 pi. This also has a vertical shift because there's something added on the end. So the vertical shift would be up 2 or plus 2. So this has a little bit of everything happening. This is about as complicated as I can make one of these. So before we start our graph, let's think about what this would look like. I would be starting to the left 3 pi. It's going to take me 6 pi to finish my graph. So 6 pi to finish my graph, 1, 2, 3, 4, 5, 6. This whole distance, if that whole distance is 6 pi, that means it's going to finish at positive 3 pi. So this one's actually going to be evenly split on the x-axis. Now, as far as the y-axis goes, I'm shifted up 2 with an amplitude of 4. Okay, so again, let's think about what that's going to mean. This thing is going to start up 2, and then from 2, I'm going to go up 4, which from 2 to up 4 would put me at a peak of 6. From 2, I'm going to go down 4, which will put me at the bottom of negative 2. Again, that means this is a distance of 4, and this is a distance of 4. So I'm going to see more of the above x-axis, but I will see the same dip below. So for my graph, I'm going to draw it something like this. So starting at the horizontal shift, which again is to the left 3 pi. If I add my increment 4 times, so negative 3 pi, plus the increment 3 pi over 2. Well, with common denominators, that would be negative 6 pi over 2 plus 3 pi over 2. That gives me negative 3 pi over 2. Oops, over 2. So my next increment is at negative 3 pi over 2. If I take that and I add the increment again, 3 pi over 2, that would put me at 0. So 0 is actually going to be one of my increments this time. If I'm going to put that 0 off to the side here, just because I know I'll need stuff on the y-axis. If I take 0 and I add 3 pi over 2, That will give me my next increment, which is going to be positive 3 pi over 2. And then if I take 3 pi over 2 and add another 3 pi over 2, that will give me 6 pi over 2, which is 3 pi. So it looks kind of funky, but the distance from here to here is 6 pi. Now, as far as the y-axis goes, well, actually, sorry, my starting line vertically is back here at negative 3 pi. For the y-axis, oops, try to do a little adjustment here so we can see a little more. There we go. For the y-axis, I'm starting up 2. So that's going to be my new midline vertically. And from that, I'm amping 4. So as we mentioned before, that's going to put me at a peak of 6 and a bottom 1, 2, 3, 4 down at negative 2. So horizontally, I'm going from negative 3 pi to 3 pi. Vertically, I'm going from negative 2 to 6. All right, now that I have all that set up, now I can actually figure out what I'm graphing. I'm graphing cosine this time. Cosine usually started above the midline. Cosine did this. There is no reflection, so it is going to start above. So what that means is back here at negative 3 pi, I'm above the midline at 6. At my next increment, which is negative 3 pi over 2, I'm on the midline. At the next increment, which is a 0, I am below. At the next increment, 3 pi over 2, I'm on. And at the last one at 3 pi, I'm above. That does not look good, but something like that. Again, that one had everything possible in it. That's got all the possibilities except a reflection. That's the only thing I didn't do on that one. For the last 2 problems on this, these are a lot easier. Now I'm giving you the graph, and we have to write a function that matches it. Well, let's think about what we can see. On letter A, notice that it's starting in the middle, so it would make sense to call this a sine function. Notice that I'm going 2 from that middle. So that means an amplitude of 2. Normally sine goes above, but this one went below. So that must mean that it's got a reflection on it. So it's negative. There is no phase shift. There's no left or right movement. There's no vertical shift. There's no up or down movement. So the last thing I have to worry about is the period, which is how long does it take to finish its wave? Well, it goes from here to here, and then it starts repeating itself. So the period is 4. Now remember, that does not mean 4 goes into the function. Remember that we talked about 2 pi divided by the b number gives me the period, which in this case is 4. I now am going backwards and trying to figure out what b equals. So basically, I got to solve this equation for b. So if I multiply b over, I have 2 pi equals 4b, divide by 4, b equals pi over 2. That's the number that gets multiplied to x. So there's my function. So if you were given this equation that we just wrote, you would see that there's an amplitude of 2. Yes, amplitude of 2. Of reflection with the negative, yes. Most importantly, though, you would say, all right, I would take this number, and I would take 2 pi divided by that number, which would mean multiplied by the reciprocal. And that would give me a period of 4, which is what I was hoping for. On letter B, This one is starting above, which means, all right, probably thinking cosine here. The amplitude from the middle above and middle below is 3.5. There is no reflection because it's starting above like it should. So I don't need a negative. Just like the last one, there's no horizontal shifting, phase shift. There's no vertical shifting, so we don't have to worry about those. We just have to worry about what the heck is the period of this. Well, this finishes its cosine wave from here to here. Because cosine starts up top and ends back up top. Well, I'm marking that my increments are every pi over 3. Now be careful, those aren't the normal every 4 increment thing. That's just saying the increments that I decided to show you are every pi over 3, which means this ends at 2 pi over 3. So the period, the distance from here to here is 2 pi over 3. Now remember, that's the period. So what does that mean? That means that 2 pi divided by some number that's going to go in the equation is 2 pi over 3. Which you could solve this for b, but you can just see that 2 pi over something is 2 pi over 3. That something has to be 3. So the number that would go into my function is 3. So there's my graph for that one, or my equation for that graph. Okay, so that does it for 4.5, a long section. This would have in class taken us about a week to do. But that's the only notes for this week that you're gonna have to worry about.